Elizabeth. You're watching the special prom weekend episode of Statistics Daily, where we spend our prom weekend safely by discussing various statistical investigations. Today, we're interviewing Elizabeth Bajanoff about a study she did regarding three important aspects of high school: sports, advanced classes, and studying. Hi, thank you for having me. What inspired you to conduct your study? Can you give us a brief overview? As someone involved in high school sports and a variety of advanced classes, I wanted to see if students' participation in high school sports was somehow related to their advanced course load and nightly study time. To collect data, I had students from randomly selected homerooms answer a short survey. After analysis of the data, I concluded that neither the association between involvement in sports and the number of advanced classes taken, nor the association between sports involvement and nightly study time have enough statistical evidence to support them. My main focus was answering the question: does participation in high school sports impact the amount of advanced classes a student takes and their amount of nightly study time? I hypothesized that there would be associations between involvement in sports and advanced classes, as well as between involvement in sports and nightly study time. High school sports are quite time-consuming, so a student involved in more sports seasons would probably take fewer advanced classes and study for fewer hours per night. We now introduce our research expert to talk about some past research conducted in this field. In 2010, the CDC conducted a review of research articles related to the possibility of an association between physical activity and academic performance in school-aged children. In total, 406 studies were examined. Academic performance was divided into grades and test scores, overall behavior in school, and cognitive skills. The CDC considered studies that involved physical activity during gym classes and extracurricular activities. Overall, there was either a positive relationship of physical activity and academic performance, or no clear relationship between the two. More specifically, when extracurricular physical activities were examined, more than half of the studies showed that there was a positive relationship between extracurricular sports participation and academic performance. 2% of the studies showed a negative relationship. Now, I think it's time to talk about the study itself, and more importantly, what the data can show us. This presentation will discuss my study from data collection to analysis and conclusions. For a random sample representative of all students, I decided to stratify by grade level, selecting 5 homerooms from each grade level to survey, and using a random number generator as described on the slide to actually choose those 5 homerooms. For each homeroom, I emailed the link to my survey to the teachers in charge of the homerooms corresponding to the randomly generated numbers. My survey was a Google form with 3 multiple choice questions. I decided to have people select an answer instead of typing it in to avoid non-numerical answers that would interfere with data processing. Because the only answer options for each of the questions were whole numbers, I decided to treat all 3 of the variables as categorical instead of numerical. The first potential association I focused on was the one between involvement in high school sports and the number of advanced classes taken. Here's the two-way table I created to summarize the data. The column totals show a somewhat even distribution of the number of advanced classes. The greatest number of people in the sample were in one advanced class. I also constructed a segmented bar graph. This bar graph takes the people in each number of sports seasons and shows the percent of those people who are involved in each number of advanced classes, which are shown in the key to the right. Although it may look like students involved in 3 sports seasons tend to be involved in more advanced classes, there were only 7 survey respondents who played in 3 sports seasons, so we can be more confident in the results for 0, 1, and 2 sports seasons. I used the chi-squared test for association for significance testing because I treated all the variables in my study as categorical, and only a chi-squared test would be suitable for that variable type. I tested for association because I wanted to know whether or not the number of advanced classes a person takes is related to the number of sports seasons they participate in. The sample was randomly taken, satisfying the first condition. I had a total sample size of 124, which is slightly greater than 10% of the total population of students at MTHS. This raises some concern about the size of my sample. Finally, the two-way table on the slide shows expected counts, and some of the expected counts are less than 5, so the final condition for the test is not satisfied. We must therefore proceed with caution in conducting the chi-squared test for association. In my significance test, my null hypothesis was that there is no association between the number of sports seasons a student participates in and the number of advanced classes that they took this year. The alternative hypothesis, therefore, is that there is an association between the number of sports seasons a student is involved in and the number of advanced classes that they took this year. The formula on the slide is the one that I substituted numbers into as shown in order to calculate the chi-squared test statistic. I conducted this test with a significance level of 0.05, which corresponds to a chi-squared value of 32.671 in the graphical interpretation of the test. The region shaded in red in the diagram is the range of chi-squared values that will cause us to reject the null hypothesis. The chi-squared test statistic that I found was equal to 30.637, and the p-value was equal to 0.08. The test was conducted with 21 degrees of freedom. The p-value is greater than the level of significance, and our test statistic falls outside the area shaded in red in the diagram. As a result, we fail to reject the null hypothesis and conclude that there is no association between the number of sports seasons a student plays and the number of advanced classes that they took. In a type 1 error, we would mistakenly conclude that there is an association between sports participation and the number of advanced classes taken, while in reality there is no association between the two. In a type 2 error, we would mistakenly conclude that there is no association between sports participation and advanced classes, while in reality there is an association. I created a bar graph of the frequency of each number of advanced classes in the sample. The graph shows that the number of advanced classes people took had an approximately uniform distribution centered around a median of 3. I calculated a 90% confidence interval of the true average number of advanced classes taken by MTHS students, using a sample mean of 3.468, a critical value of plus or minus 1.66, and a standard error of 0.209. My confidence interval shows that we can be 90% confident that the true average number of advanced classes taken by students at MTHS falls between 3.121 and 3.815, theoretically. It would be reasonable to say that most people at MTHS take either 3 or 4 advanced classes per year. Now, let's move on to the possible association between sports participation and average nightly study time. Here's a two-way table summarizing the data. It shows that most people study anywhere from 0 to 5 hours per night, and only 2 people in the sample study for 6 hours per night. This segmented bar graph takes the people in each number of sports seasons and shows the percent of those people who study every night for each of the amounts shown in the key. It seems that most students involved in 0, 1, and 2 sports seasons study anywhere from 1 to 3 hours per night, while the data for the students involved in 3 sports seasons may not be an accurate representation of all students who play for 3 seasons. As before, I used a chi-squared test for association because all the variables were treated as categorical, and only a chi-squared test could be used. I tested for association because I wanted to know if sports participation and nightly study time were related in some way. The condition for randomness is once again satisfied, and there is a concern about sample size as there was previously. In the table of expected counts, we see that not all of them are greater than 5, so the final condition for the test is not met. We must therefore proceed with caution in the significance test. My null hypothesis for the chi-squared test for association was that there is no association between the number of sports seasons a student plays in and their average nightly study time. The alternative hypothesis, therefore, was that there is an association between the number of sports seasons a student plays in and their average nightly study time. The formula on the slide shows the general formula used to calculate the chi-squared test statistic and the numerical calculations conducted using that formula. I conducted the test with a level of significance of 0.05, which corresponds to a chi-squared value of 32.671. Any chi-squared test statistic greater than 32.671 will allow us to reject the null hypothesis. The chi-squared test statistic I calculated was 11.671, and the p-value was 0.864. The p-value is greater than the level of significance, and our test statistic falls outside the area shaded in red in the diagram. As a result, we failed to reject the null hypothesis and conclude that there is no association between the number of sports seasons a student plays in and the number of advanced classes that they took. In a type 1 error, we would mistakenly conclude that there is an association between sports participation and average nightly study time when there is actually none. In a type 2 error, we would mistakenly conclude that there is no association between sports participation and average nightly study time when there actually is an association. As can be seen in the bar graph, the distribution of the average nightly study time for my sample was slightly skewed to the right, but still relatively close to normal. I calculated a 90% confidence interval of the true average nightly study time for MTHS students, using a sample mean of 2.435, a critical t-value of plus or minus 1.66, and a standard error of 0.133. I found that we can be 90% confident that the true average nightly study time for MTHS students falls between 2.214 and 2.656 hours. The results of the chi-squared test for association between sports participation and number of advanced classes taken show no association between the two variables. This shows that our school offers a great deal of flexibility for student athletes, and nobody feels pressured to choose a less rigorous course load to accommodate for an increased number of sports seasons. According to the chi-squared test for association between sports participation and average nightly study time, there is not enough statistical evidence of an association between the number of sports seasons someone is involved in and how much they study every night. This shows that although sports at our school are a significant time commitment, people involved in athletics are still able to find enough time to study every night. One weakness of my study was the potential for multiple responses from the same person. This caused there to be 2 instances of a response where someone claimed to participate in 3 sports seasons, be in 7 advanced classes, and study for 10 hours every night. I had to eliminate these 2 data points because such a combination would not be feasible. A more general weakness of my study was the potential for non-response bias. I shared a link to my survey instead of a QR code, which made it more difficult for teachers to share the survey with their students, and fewer people than expected filled out my survey due to difficulty in accessing it. Is there a way to extrapolate some of your findings to a wider population? I would feel comfortable extrapolating my conclusions to students from high schools that, like MTHS, are suburban public schools and are similar to our school in size and course offerings. The range of courses, extracurricular activities, and overall academic environment may differ if a school is in a rural or urban area or if it is private or public. These factors may impact students' priorities regarding studying, advanced course selection, and sports participation. And now I have a question for our research expert. Based on what we've heard, is there any further research to be done related to the subject of sports participation, advanced course selection, and study habits? In order to more comfortably extrapolate our results to the entire population of American high school students, we would have to conduct this study on a wider scale, stratifying by geographic region instead of by grade level. In each region, we could then randomly select a certain number of private schools and public schools to ensure that different school types are represented. The students at those schools would be asked to fill out the survey used in this study, and the results would be analyzed as they were before. This has been another episode of Statistics Daily. Thank you to everyone for watching, and we'll see you later.